Hello there, welcome to this lesson. Still looking at measurement, and we are moving on to mass and temperature. Mass, we are talking about the quantity of a substance in a given item. So what is this quantity that the item is holding? Then temperature, we are simply talking about the degree of hotness or coldness of a given item. So whenever we are talking about mass and temperature, then there are various units that are used in measuring mass and temperature. So we just want us to look at some of the units that are used in measuring mass. Then we will look at the units that are used in measuring temperature. So these are the metric units of mass we have. We are talking about 1 gram. Whatever we have in brackets are the symbols for the given units. So 1 gram is equal to 1,000 milligrams. 1 kilogram is equal to 1,000 grams. And we have 1 ton is equal to 1,000 kilograms. So these are the metric units of mass that are used. So we can try and find out the items that we have around us and try and weigh those given items and find out what is the mass of the given items. So you can weigh the mass of the textbook you have, you can weigh the mass of your pen, you can weigh the mass of any item that you have around you and find out which unit of mass is most appropriate to be used for the items that you are having. So these are the units of mass that we have. We shall be looking at how we go about working with these units of mass. At the same time, we are talking about the units of temperature. So the units we have that are used to measure temperature, we have the degrees Celsius and we have degrees Fahrenheit as the units used to measure temperature. The most common, we use degrees Celsius when measuring temperature. So we can measure the temperature of a given room, the room that we are in. We can try and find out at what temperature is the room temperature that we are in. We can try and measure the temperature of some drinks that you are taking, maybe water, coffee, or whatever drink that you are taking. You can try and find out what is the temperature of that given drink. At the same time, we can try and measure temperature, the body temperature of a given person. So we can try and find out at the body temperature of different individuals in the room so that we are able to identify in what degrees Celsius is our body temperature. So these are the units that we are going to work with in this topic. As we are dealing with mass, we keep in mind we have grams, milligrams, kilograms, and tons. As we are dealing with temperature, we are talking about the major unit of temperature that we are going to be using is the degrees Celsius. So with this in mind, can we just try and tackle some few questions that are involving mass and temperature for us to be able to understand what we mean by this mass and temperature. So looking at this question, we are given options A to F, and you are supposed to choose the mass that best matches whatever we've been given in this given question. So the first item that we need to find out which mass amongst whatever we've been given will best suit whatever we have here. The first item is human hair. We need to find out what is the suitable mass for the human hair. So whatever we are having, we have 300 grams, we are having 40 kilograms, we have 100 milligrams, 1.5 kilograms, 13 tons, and 5 grams. That is whatever we have. And we need to find out a human hair. Try and weigh. Get some human hair and try and weigh the human hair and find out what range are we likely to get as the mass of that given human hair. And we find that from whatever we have on this detail, we don't expect that the human hair that we have will weigh in kilograms. We don't expect it to be in tons because this is a very large mass that we have. So most likely, depending with whatever we have, we can try and find out this human hair that we are having from maybe the milligrams, the lowest unit of mass that we have as the mass of the human hair. So looking at this, what we have in this, we are doing away with the kilograms and tons because we cannot carry kilograms on our head and tons on our head. It is very much impossible because these are very heavy. So it can't be 40 kilograms, it can't be 1.5 kilograms, and it can't be 13 tons. So whatever we are left with 5 grams, we have 100 milligrams, and we have 300 grams. But most likely, maybe we are talking about some strands of human hair. We are not carrying a whole basket of human hair. So having the human hair, then we will pick our unit to be the 100 milligram. Next, we have the 10-cent coin. We can have the coins and try and find out the weight of a coin. So a coin is also not a very big item that is being carried around. So we don't expect a coin to be in kilograms, and at the same time we don't expect this coin to be in tons. So the weight of this coin, 300 grams. We don't really think that a coin can go all the way to 300 grams. So what we are left with is the 5 grams. So the weight of our coin should be around 5 grams. Then a bottle. We can try and have different bottles and try and find out the weight of the given bottle. So we pick the 300 grams for our bottle, depending with the size of bottle we have, but we are picking on 300 for this case, so that our bottle will be 300 grams. Then next we have a large book, so we can try and weigh a large textbook and find out what is the weight of the textbook or whatever book that you're having, a very big book. So having that big book, we try and find out what is the weight, what is the mass of that given book. So a large book is likely to weigh the 1.5 kilograms. A large book is likely to be weighing the 1.5 kilograms. Then we have large bag of sand. So a bag of sand you've packed your sand in a bag. The bag of sand is likely to be weighing 40 kilograms. Then finally we have a truck. A truck will definitely be weighing in tons because you don't expect a truck that is lower than that value of the tons. So a truck should be around the 13 tons. So this is just a question that is trying to enlighten our mind and find out what could be different measurements, the different masses for the different items that are around us. Try and weigh some different items around you and find out what is the mass of whatever item you have. So looking at this, it can at least give us the direction and a way forward of whatever masses to be expected as you are weighing the different items that we have. After looking at these masses, let us compare the temperatures of given, let us also identify temperatures of different items and find out what could be the temperature of those given items. So from options A to D, we are to choose the temperature that best matches the description that we've been given. So we have a description, then we have the temperature on the other end. So the first description we have is the temperature of coffee. So this is coffee. We need to find out at what temperature will this coffee that is being taken by a person be at. Looking at these temperatures, we are having 15 degrees Celsius, we have 50 degrees Celsius, we have negative 20 degrees Celsius, and we have 250 degrees Celsius. This is coffee that is supposed to be taken by someone. It is very unlikely that it will be at 250 degrees Celsius because this is too high. It can't be at a negative value because at a negative value, the coffee will be too cold to be taken. Then we are talking about 15 and 50 degrees Celsius as the options that we are left with. This is coffee that has been warmed, so we are expecting that the temperature of this coffee will be at 50 degrees Celsius. Next, we have temperature of water. So you are taking water from a given tap or somewhere. So the temperature of water, when it goes to negative, then it definitely means that it will be ice. We will no longer have the water. Then we are having 250, that will be too high because boiling point of water is 100. So we are expecting that the temperature of this water that is being taken should be at around 15 degrees Celsius. Temperature of oven. Oven is a place that is used to heat up materials, and the temperatures are extremely high. So we are expecting that temperatures in an oven can go up to 250 degrees Celsius. Then temperature of Antarctica, definitely we are left with negative 20 degrees C. So that means that Antarctica is a region in the poles where the temperatures are extremely low. So being extremely low, then we are expecting that the temperature can go up to negatives. So we have a temperature of negative 20 degrees C. So another question that we are having is that we've been given the mass in one of the units and you are asked to convert it to the given units in brackets. So the first one, we have 2 tons, and we are supposed to convert the 2 tons to kilograms. So we had the metric units of mass earlier on, hoping that we still have our table. Let us just look at our conversion for the tons to kilograms, and we know that 1 ton is equal to 1,000 kilograms. We are having 2 tons, 1 ton is 1,000 kilogram. What about 2 tons? So that means we simply cross multiply. This is 2 times 1,000, so that we have 2,000 kilograms. So 2 tons are equivalent to 2,000 kilograms. That is the first part of our question. The second part, we have 70 kilograms, and we need to convert the 70 kilograms to grams. So converting 70 kilograms to grams, so the relationship between kilograms and grams, we know that 1 kilogram is equal to 1,000 grams. What about 70 kilograms? So this means that we cross multiply. We will have 70 multiplied by 1,000, so that we have 70,000 grams. So that means 70 kilograms are equal to 70,000 grams. So the first and the second part, we are through with that. We can move on to the third part. So we have 2.4 grams, and we need to convert 2.4 grams to milligrams. So first we need to find out what is the relationship between grams and milligrams, and we know that 1 gram is equal to 1,000 milligrams. We are having 2.4 grams. So what about the 2.4 grams? That means we simply cross multiply and get 2.4 multiplied by 1,000. When we are multiplying by powers of 10, then it means the decimal is moved to the right. So we have 3 zeros, so we move our decimal point 3 steps to the right, so that our answer will be 2,400. So this is 2,400 milligrams. So that means 2.4 grams is equal to 2,400 milligrams. Next, we have 2,300 milligrams. We need to convert the 2,300 milligrams into grams. This was conversion from grams to milligrams, but now we want to look at the other way round, where we are having the milligrams and we are required to find the answer in grams. So still having the same conversion, we know that 1 gram is equal to 1,000 milligrams. Then we have 2,300 milligrams. How many grams are there? So 1 gram is 1,000 milligram. What about 2,300 milligrams? How many grams do we find in 2,300 milligrams? So this means if we cross multiply, then we have 1 multiplied by 2,300 divided by 1,000. So when we are dividing by powers of 10, then our decimal point is moved to the left. So we have 1,000, those are 3 steps to the left. So it means we have 1, 2, 3. So 3 steps to the left, it brings us to 2.3 grams. So that means 2,300 milligrams is equal to 2.3 grams. The other part we have 4,620 milligrams, and we need to convert the 4,620 milligrams to grams. So we are still using that conversion. So we are still having 1 gram is equal to 1,000 milligram. What about 4,620? So cross multiplying gives us 1 times 4,620 divided by 1,000. We've already said that when we are dividing by powers of 10, then our decimal point is moved to the left. So we have 1, 2, 3 steps to the left, and it gives us 4.62 grams. So we discover that when you are moving from a smaller unit to a larger unit, then we divide. But when you are moving from a larger unit to a smaller unit, we are supposed to multiply. Let us just write whatever we've been having on this board here. We are talking about the units. We have milligrams, so those are the units we are having. So this is the smallest unit we have, and that is the largest unit we are having, and we are converting from one unit to another. So this is whatever we are saying, that when you are converting from the larger unit to the smaller unit, then we are multiplying. So in this case, converting from tons to kilograms, we multiply by 1,000. Converting from kilograms to grams, you also multiply by 1,000. And converting from grams to milligrams, we multiply by 1,000. In the other way, converting from milligrams to grams, then we divide by 1,000. Converting from grams to kilograms, we also divide by 1,000, and converting from kilograms to tons, we divide by 1,000. So when you are converting from the smaller unit to the larger units, we divide, and when you are converting from the smaller unit, the larger units to the smaller units, then we multiply. So this is the idea that we need to work with when we are converting from one unit of mass to the other. So another question we have, a small truck delivers 0.06 tons of stone for a garden. We need to write the mass of stone in the units that we've been given. The first unit is we convert the 0.06 tons to kilograms. So if working out the first part, we are talking about 1,000 kilograms being equal to 1 ton, so that we need to find out the mass of 0.06 tons in kilograms. So when we cross multiply, then it means we have 0.06 multiplied by 1,000. So we are multiplying by powers of 10. We move our decimal point 3 steps to the right, so that we have 1, 2, 3. This gives us 60 kilograms. So converting 0.06 tons to kilograms then gives us 60 kilograms. Part B requires us to find the value of this mass in grams. So this is in kilograms. We work out in grams. So we already said that 1 kilogram is equal to 1,000 grams. So what about 60 kilograms? So this means we have 60 times 1,000, which will definitely give us 60,000 grams. So when converting the 0.06 tons to grams, we get that we have 60,000 grams. Then finally we find the mass in milligrams. So we already have the mass in grams. We simply use the conversion. We are talking about 1 gram is 1,000 milligrams. We are having 60,000 grams. How many milligrams are there? So that is 60,000 multiplied by 1,000, which will give us 60 million milligrams. So that is the conversion from tons all the way to milligrams. So we've converted to kilograms, we've converted to grams, and we've now converted to milligrams. I've just drawn a scale showing temperature of a certain item, and we need to give the reading of this given temperature. So at times when the scale has been drawn, you just need to find out what is there in that given scale. So in this case, this scale of temperature that we have has a range of 5, so that every subunit is 1 degree each. So we need to give the reading of this scale. This is just temperature in degrees Celsius, so that we already have 10 degrees Celsius. This is 11, this will give us 12. So it means whatever item that is being measured in this case is at a temperature of 12 degrees Celsius. So when we've been given a diagram, a reading, a scale of temperature, and we are required to get the temperature of that given item, it is just easy to read from that given scale. Just find out what your scale is, then go ahead and get the reading from that given temperature. So just a question on temperature that will help us understand what we are dealing with in temperature. We can just try and write it down as I read for yourself. So whatever we are having is this, that the temperature of water, so we have temperature of water this temperature of water initially is at 95 degrees Celsius. So the temperature of water initially is at 95 degrees Celsius. Then after a half an hour, the temperature is 60 degrees Celsius. So initially the temperature was at 95 degrees Celsius, and after a half an hour the temperature drops to 60 degrees Celsius. And the question is, what is the drop in temperature? So we have the initial temperature of this water was at 95 degrees Celsius. After a half an hour, the temperature drops to 60 degrees Celsius. We need to get the difference in temperature. The difference in temperature is simply obtained by subtraction. So this means we have 95 degrees Celsius minus 60 degrees Celsius, so that we have 35 degrees Celsius as the difference in temperature. So this temperature dropped by 35 degrees Celsius. So whenever we are given a question to work out, be it in mass, be it with temperature, then it is just our common knowledge that you need to understand what the question is requiring you to work out. Are you required to convert from one unit of mass to the other? Are you required to find out the difference in temperature? Are you required to get to understand which one is larger, which one is smaller in that given case, so that you are in a position to understand whatever you are being directed to do in that given question. So when you are given a question on mass and temperature, just read the question, understand, find out what are you required to do in that given question. Depending with what the question directs you to work out, then you can be in a position to work it out as long as you've understood what the question requires us to do. So we can try and work out this question for us to be able to understand much better whatever we mean by the mass. The question requires us to arrange from the smallest to the largest. So we have a list of masses, and from these masses we need to arrange them from the smallest to the largest. So this is the list of masses we have. So we have 2.5 kilograms, we have 370 grams, 0.1 tons, and 400 milligrams. So these are the masses we have, and we need to arrange them from the smallest to the largest. Looking at it, we find that the masses that we have, we've been given in different units. We have kilograms, we have grams, we have tons, and we have milligrams. So when they are in different units, there is a high chance of someone making a mistake. The person can easily assume that the unit that is having the larger figure could be the largest, and the unit that is having the smallest figure could be the smallest, which is a wrong perception to have. So the first task we have, we need to convert whatever units we have to the same unit for us to make a comparison with items that are in the same unit. So we can choose any given unit that we can convert our units to. Let us maybe convert the units to grams. We can convert all that we have in these to grams, and after converting to grams, we then compare the units that we have. So the first task we have 2.5 kilograms. Converting the 2.5 kilograms to grams, we've said that when you're converting from a larger unit to a smaller unit, we multiply. And kilograms to grams, we will multiply by 1,000. So 2.5 multiplied by 1,000 gives us 2,500. We have, this is 2,500 grams, The other one is already in grams, so this is 370 grams. We need to convert 0.1 tons to grams. So we convert it first to kilograms, and we know that when you are converting tons to kilograms, we multiply by 1,000. So I have 0.1 times 1,000, which will give me 100 kilograms. Then from the kilograms, we convert it to grams by multiplying also by 1,000, so that we have 100,000 grams. So the next mass we have is 100,000 grams. We have 400 milligrams. We need to convert the 400 milligrams to grams. We simply convert 400 milligrams to grams by dividing by 1,000. So we have 400 divided by 1,000, which gives us 0.4 grams. So after converting the units we have to the same unit, then it is easier for us to make a comparison. So from here, we can easily tell which one is smaller. So looking at the digits that we have, we can tell which one is smaller, which one is larger. From these given digits, we discover that 0.4 is the smallest. So arranging from the smallest, we have the 0.4 grams. Then 0.4 grams is followed by 370 grams. From 370 grams, we have the 2,500 grams. And finally, we have 100,000 grams. But these are not the units that we were initially given in the question. So after we've rearranged using the units that we converted, we can now confirm whatever units they were in our original question, so that we get to write it down. So 0.4 grams was initially 400 milligrams. So this means we start with 400 milligrams. 370 grams, it was there, so this is still 370 grams. 2,500 grams was representing 2.5 kilograms, so this is 2.5 kilograms. And 100,000 grams was representing 0.1 tons, so this is 0.1 tons. So we've arranged whatever we have in order from the smallest to the largest. This is the order that we have of the masses from the smallest to the largest. So that is about the measurement. And when we are dealing with measurement, we've just looked at various things. Measurement as a topic, we've looked at length and the units that are used to measure length. With length, we looked at various units. We talked about the Egyptian system of measuring length. We talked about the Roman system of measuring length. We talked about the imperial system of measuring length. And we said the most common system of measuring length was the metric system. And with this length, we talked about the units of length. The metric systems of length, the units we were dealing with: meters, we talked about centimeters, we talked about the kilometers. Those are the metric units of length. From this length, we've looked at the perimeter. Looked at perimeter of various figures. We've looked at perimeter of a rectangle, perimeter of a square, perimeter of the combined figures. Then we looked at the circumference, and we said that circumference is distance round the circle. Then from the circumference, we looked at part of a circumference, which was an arc, and the arc brought us to the section of a circle, and the section of a circle is simply said that it is that part that is surrounded by an arc and the two radii. So from there we've gone to area, and the area we've looked at the area of a rectangle, area of a square, area of a triangle, and area of a parallelogram and the combined figures. Then from that we have the mass and temperature as another part of the measurement. So looking at all these, it means that it brings us to the end of the topic measurement, and hoping that with that we can be able to work out any question involving measurement as we try and work out the sums that we have. So thank you.